welcome back to course Big Data Analytics and Business Intelligence. So our today's topic is Introduction to Multidimensional Data Model with star and snowflake schema. So here we are going to understand what is a multidimensional data model, and we understand what is a star schema and the snowflake schema. So first of all, we understand what is multidimensional data model and why there is a need of a multidimensional data model. So generally we use x-axis and y-axis to represent a two-dimensional data. So again we can use z-axis to represent a data in a three-dimensional format. But suppose we want to represent our data more than two dimensions, so what we need to do? So there are certain situations where we need to visualize your data by using more than two dimension or more than three dimensions. So at that time you require a multidimensional data model. So see, first of all I will just explain one example. So this is a simple table which represents the data of a sales. Okay, this is a table which represents the sale data. This table consists of four attributes: product ID, time ID, location ID, and the sales number of products sale. So that is representing. So this table is going to represent the sales data. So this is what a tabular representation of a data. But suppose we want to represent the data by using multidimensional data model, then we can make use of a data cube. So multidimensional model views the data in the form of data cube. So what do you mean by data cube? This is what a data cube. We are representing the data in the cube format, and it is having a multiple dimension. It is not only having x-axis, y-axis and z-axis, but it is also having more than 3 axes. So as I told you that whenever you need to represent your data, you need to visualize your data with more than 2 or 3 dimensions. At that time multidimensional data model can be used. So data cube enables data to be modeled and view in a multiple dimension. And this data cube consists of two things. One is a dimension and second one is a fact. So here we try to understand what do you mean by dimension and what do you mean by fact. So first of all, fact is nothing but a in this case company sale. Okay, fact is nothing but a company sale. So what we are representing? Sales data. So this is considered as a fact. Suppose we are representing the information about the student, so we can say that student data is a fact. And next thing is dimension. So what do you mean by dimension? Dimension is nothing but attribute which represents that particular fact. For example, in this case, in order to represent the sale, we are considering 4 attributes: product ID, time ID, location ID and the sales. In the another way, in the student example, I can say student data is a fact, and the roll number of the student, percentage of the student, contact number of the student and address of the student considered as a dimensions. So multidimensional data model consists of facts as well as the dimensions. So this is what a table, and we can represent this. So here we try to understand how multidimensional representation given for this particular table. So I told you this is a sales data having 4 attributes. So here you can see here we observe what are the time ID. So there are 3 time IDs there which we have represented on this axis. Time ID is 1, 2, 3. Then on this axis we are representing the product ID. So here there are 3 products are there: 11, 12, 13. Then in this particular axis we are representing the location ID. So location ID is 1 and 2. And then here we are representing the sales data. So the dimension of the cube is going to vary depending upon the data present in the table. It's totally depend on what amount of data present in the table. So according to that, the size of your data cube is going to be vary. So this is what a multidimensional data model. So multidimensional data model can also be represented with the help of the 2 type of schema. One is a snowflake schema and another is a star schema. So first of all, we try to understand the star schema. Okay, first of all we try to understand the star schema. So star schema, as its name suggests, it represents your data in the form of star. Here this is a simple diagram which represents this thing. So here you can see as its name suggests, star schema is that schema which represents your data in the star like a format, which consists of 2 things. One is a fact table and second one is a dimension table. again the same thing is there. What is a fact? Just we understand, company sale is a fact, and product ID, location ID, sale, the number of quantities of sale, these are considered as the dimension, or you can say, yeah, these are called as a dimension. So this is represented with this star like a structure. So it is an elementary form of dimensional model in which data is organized into fact and dimension, that we have seen in case of multidimensional data model. Two things are there, one is a fact and second one is a dimension, and the center of the schema consists of a fact table, and its point of the star is going to represent the dimension table, fact table and dimension table. And so in this case, what is fact? We understand fact table means what is a, what you can say about fact table? It contains the fact and it is connected to dimensions, and at the point there will be a dimension table. So we'll take a simple example to understand the star schema. So here you can see, suppose I need to represent the revenue of a particular company. So for that purpose, suppose I decide to use a star schema. So I know that star schema consists of two things, one is a fact table and second one is a dimension table. So what is a fact? Revenue of a particular organization is a fact, and what are the dimensions? Date of that what is the date for that revenue, product, branch, as well as the dealer. So these are considered as a dimension for this fact revenue. So they are having their attributes. In this case, date ID is a primary key. In case of product ID is a primary key. In case of a dimension table, branch ID is a primary key. In case of a dealer ID is a primary key. So we consider that this is a parent table and these are the child tables. So in case of star schema, we know that fact table act as a parent table, whereas dimension table act as a child table, so which stores which is having their own primary key. Okay, so this is a parent child kind of relationship is there. Okay, here there is a parent child kind of relationship exists in this star schema. Next we understand what are the features, what are the main features of a star schema. So every dimension in a star schema is represented with only one dimension table. So here you can see every dimension is represented by one dimension table. These are 4 dimensions which are represented by dimensions of the table. These are the 4 dimensions of the table, and the dimension table should contain set of attribute. Here one of the dimension is product, and the product ID, product name, model ID, variant ID, these are called as attributes. Dimension table are not joined to each other. Here you can see product table is not joined to date table, dealer table, and the branch table, but it is directly attached to only fact table, that is revenue. This is another feature of this star schema. Fact table would contain key and measure, and this star schema is easy to understand because its structure is very simple, and this schema is widely supported by a number of BI tools, just like Tableau, MicroStrategy. This tool supports this star schema very well. So I hope you understand star schema, how your data is represented with the help of star schema. Next we discuss what are the benefits of star schema. So star schema, it helps to improve the performance of a query, then load the performance administration, built-in referential integrity, just we have seen here, parent-child type of relationship there, that means foreign concept of foreign key is there, and it can be easily understood because of simplicity of its visualization. So these are the various benefits, and one of the drawback of a star schema is that we cannot represent many-to-many relationship. This star schema works on the concept of one-to-many kind of relationship, but many-to-many kind of relationship is not represented with the help of star schema. So that problem is overcome in the snowflake schema, that we understand. So then second type of schema that we are going to discuss is what a snowflake schema. So snowflake schema means what? It's a schema. This schema is known as snowflake because if one or more dimension table do not connect directly to fact table but just join through other dimension tables. So here you can see this dimension table dimension table is not directly attached to fact table, but all the dimension tables are connected with this, and then this one dimension table is connected to fact table. So this is what a snowflake is, just like a chain. So ER diagram resemble the snowflake shape. Here you can see these are the dimension table. So dimension tables are not directly attached to fact table as that in the star schema. In case of a star schema, what is your observation? Here you can see all the dimension tables are directly attached to the fact table, and they are, all the dimension table are not attached with each other, so they are not going to represent the many to many kind of relationship, only represent a one to many relationship. So this problem is overcome in a snowflake schema. Here you can see many to many relationship can also be used. So this is what a diagrammatic representation of a snowflake schema. Next we try to understand the example. So this is again same revenue table. Revenue fact is our revenue. Again snowflake schema basic is same, it make use of fact table and the dimension table. Fact is nothing but revenue of a particular organization, and the dimension is nothing, different dimensions are there: dealer, branch, country, location, date, product, variation, all these are the dimensions. So this is what a example of a snowflake schema. Here you can see all these are the dimension table. So all the dimension table are not directly attached to fact table, but they are initially attached to it, and then it is directly connected to fact table. So this is what a structure of a snowflake schema. Finally we discuss what are the benefits and drawbacks of a snowflake schema. So advantages is its improved performance due to minimized storage, no redundancy, so it is easier to maintain. And if you talk about the disadvantages, then there are more complex queries, hence difficult to understand, and more table, more join, and you know that if more join will be performed, then the complexity is also increases. So these are the various advantages and drawbacks of a snowflake schema. So I hope you understand what is multidimensional data model, how it helps to visualize your data in a multiple dimension. And there are two schemas are there are two types of schemas are there. One is a star schema, which represents the data in the star like format, where second is a snowflake schema. So major problem with the snowflake schema is that it cannot represent many to many relationships, so that problem is being overcome by snowflake schema by allowing many to many kind of relationship. Thank you.